So just for context, everyone, like I have the baby bit logo up here because, put yourself in my shoes, really want you to live this experience with me. I'm young into my career. I'm not really very confident in my skill set, but, I'm excited and I've got my manager that approaches me and says, like, when we have this process that we want you to build a solution end to end, he didn't say you have to use a specific service, you got to do it a specific way. I was kind of just tasked with this, right? So, here, very grateful for the opportunity, excited, nervous, and things, right? So this is the context of this project, right? So let's talk a little bit about what the actual problem was that needed to be automated. So I had two colleagues that were spending their mornings manually submitting files to a website, and I've highlighted here words that I think are sort of key to this problem here. So they were spending their mornings manually submitting files to a website. And this combined 3 hours between both of them every single day and 6 days a week, because this is a process that needed to be done Monday through Saturday. This was in the energy industry. I don't know if anyone has any experience working with the energy industry, but they have all sorts of rules, limitations, very old processes as well, things that have to be submitted. It's weird because there's some stuff that has to be submitted like exactly 9:59 in the morning. And if it's 1 minute after, it's considered the next day, a bunch of different things. So if anyone has any experience in the industry, in the energy industry, let me know in the chat. But anyway, so the total was 18 hours of manual work a week, right? And I've actually got here a representation of my frustrated colleagues that, they just wanted to spend their time, this 18 hours of time that they have per week, doing things where they're actually working on the skill set that is specific to their role and not just doing something that you could automate, something that was manual, something that was really sort of boring and whatnot, right? Wanted to spend their time more mindfully. And I think this is also important when we think about automation, because when we think automation, we think people lose their job. But if you work at the right place, you've got the right team around you, you've got the right management and leadership, they can turn that time that was saved into more mindful work for your team, which is what ended up happening in this process, which is great. But anyway, now let's talk a little bit about the approach. Again, still, young Gwen, early in career, still baby bit here. But through conversation, I sat down with the team who were actually doing this process, and I'd figure out, okay, there's some key facts here that makes me think that I should use a serverless approach here. So anyway, first of all, again, this is our team here sitting in a co-working environment. But anyway, first of all, the whole process I knew for each file to be submitted would take a few minutes. So it wasn't a long running. It wasn't something that needed to run for days or hours or anything like that. So from them getting the file to submitting it to this website, it was a couple of minutes. So that's a key fact there. Then I also knew that these files could be processed independently. So none of these files depended on each other. It was one file, upload, submit, done, move on to the next file, which is important. And I think there was at that point when I first created the solution from 50 to 60 files, but the goal was to have more and more files depending on more clients coming in and whatnot. But again, order didn't matter. They didn't have to be done together. They just had to be processed at some point. Important here too. Another key fact here that I found out was that each file had a username and a password that rotates each 90 days. So in order for whatever process that I was going to create, it needed to be able to securely access these credentials. And these credentials also needed to be in a place that we could, in a streamlined way, update them because they needed to be rotated every 90 days, right? So it's also important here. Then I knew that the files that actually get uploaded were generated by an existing system, and then these analysts, my colleagues, were downloading the files from the existing system manually. But I spoke to the lead engineer on that project, and then he essentially told me, like, yeah, we're just sort of generating them and not putting them anywhere. But if you gave me a place where you wanted them to go get saved, I could do that for you. So I was like, okay, cool. Key fact right there, too. So I know I could get the files to get, once they were generated, to go somewhere where I needed them to go. Mm-hmm. Very, very important part is the website where we were actually uploading these files to had an API. So if you are a developer, you do any engineering work, APIs are important when it comes to automating and having systems communicate with each other. If it didn't have an API, we were probably looking at using like, what's that technology that you can, or that service that you can use to automate like clicks in a website? I can't remember.
Oh yeah, there is something. It's basically, you can crawl.
Yeah, something like that. But it would have made this process a lot more difficult. But the way that I found out that this website had an API, and again, we're thinking energy industry, was kind of frustrating because I had to email their support team, wait a week to get a response back. And they emailed me back a 60-page PDF that was, to be fair, it had everything, but I had to literally go through the entire thing to get, okay, you need to have this type of information in the headers. You need to like submit this type of information. Here's the URL and whatnot and things like that. Responses to expect and all that kind of stuff. So key fact here, the website had an API. Finally, I also knew that it was important that the website response itself was important because it needed to be, if it wasn't a success, the file needed to be processed again. But it was important that every single file get processed. And even if it was successful or not successful, that response was going to need to save somewhere because my colleagues were going to need to be able to see, okay, just to verify the manual verification there, everything looks green. Perfect. Okay. So let's talk about this. Let's in steps. So I have this the key facts, and I'm like, okay, so now I understand the actual manual process. And when you're automating something, it's very important that you understand every single bit. So it's like, think about like when you're trying to change a light bulb. It's not like, oh, just change the light bulb. Like, no, it's like step one. Do you have, is it the light bulb the actual issue? Like turn the light on. Is the light working in other places? Okay, you figured out the light bulb. Do you have an actual spare light bulb? You don't want to go up to go change your light bulb and it turns out you don't have a spare light bulb. Then you got to go to the store, right? So when you think about automating a manual process, it's all about every single little step and everything that could go right and wrong and is expected and whatnot. All right, so let's talk about the steps here. So first of all, we know that we have to get the files to automatically go somewhere once they are made available by that existing system. And we know that for that requires the change in that existing system to be done by the team that handles that system. Awesome. Okay. Second step here is that I know that as soon as a file is in that place, we need to process it. The actual process, the steps and process is obtaining the file. Then we need to obtain the credential. Then we need to parse the XML because these files were XML data and that API was expecting XML. Then we needed to submit the XML with the correct credential to the API. If the API returned a successful response, we needed to archive the file because it's been processed. We don't need it anymore. And when you have like a hot storage versus archive storage, there's a significant price reduction in storage that you use just for archiving. So the more we can save money, the better. And if the API didn't return a success, we don't move the file. We have to leave it in the same place that it is so it can get processed again. Fantastic. Then we need to, regardless of what the response is, save the response somewhere, save the API response somewhere. And also I mentioned that we needed to be able to update credentials and we also needed to be able to see the actual responses. I like this comment, XML the horror. Yes, I'm more of a fan of JSON myself, but hey, XML exists a lot and is still very used in many, many places. But yes, it would have been so much easier to work with JSON, but yeah, we have XML there. So anyway, additional tools, we need to create a credential updater. Yes, of course, because we need to interact with this service that was going to share, was going to keep the credentials. And we needed to build some sort of static website that my colleagues could just visit and they go to the website and they see all the results and then easily see it's green, green, green. If there's something red, then, oh, they have an idea of what needs to get processed again. Maybe they kick off the automation process or whatever. Once more. Okay. So anyway, now we have all the steps and now we talk about the plan here. Again, still kind of like early on, not as confident, but yeah, we're going into it, right? So we got the plan. Now things are about to get, I'm warning you all, things are about to get chaotic. But that's sort of how it is when you're sort of like, you know, putting the process together, kind of figuring things out. You're kind of doing a brain dump. Things can get a little chaotic until they smoothen out and you actually figure stuff out, right? But anyway, so again, let's map these steps into Azure Services. So we need the files to go somewhere. Well, perfect solution for that would be blob storage. And like I mentioned, blob storage is essentially a serverless storage service with Azure. Okay, so I could give the blob storage the proper SaaS or token or however it is that you want to your service to connect to. I know I think it was like a .NET application. So they were able to just get okay, these files are manually, these files are generated, we'll send them straight off to a blob container there in Azure Storage. Then I know that we need to process each file as they come in. Azure Functions is a perfect service for that. Azure Functions has a bunch of triggers and bindings. Triggers are ways that your event-driven code, which is what functions are, can execute, can run. And then blob trigger would mean that, okay, your function is expecting some sort of change in some sort of blob container, which the change in this case would be, oh, yeah, a new file is available. Let's do something with it. So we're going to use functions to obtain the file, right? And then the next step here is to obtain the credential. Now, I mentioned we have to have a safe place, safe, secure, top-notch security, where we can maintain our credential, but we also need it to be somewhere that we can update in somewhat of a streamlined way. For that, we have Key Vault. Key Vault has SDKs and APIs that you can use to securely interact and update with them, but also you can use an access policy within Azure to have your Azure functions and Key Vault talk to each other. And when we're in the solution diagram, we'll see that there's a back and forth here. But for right now, let's think of like the pseudo-code. Like before you actually code, you have pseudo-code, right? So this is like pseudo-diagram with cloud infrastructure and whatnot. Okay. So then parse XML. That was another job before the function itself, and we've got it here pointing to the function. Now, remember I told everyone there is one big change I would make in my updated solution if I were to rebuild this thing in 2022. I'm going to tell you, in this slide, you can probably get a feel for what it was, but pay attention. Okay, so anyway, then we've got to submit the XML with credential to the API, and again, regardless of the response, we need to save that too. And then we need to the actual submission of that data will be done from that function as well. Next, we've got to save the API response. We need to actually grab that data and put it somewhere. Table storage is probably like the cheapest and more straightforward way, and you can have an output binding on the Azure function to save to table storage. So perfect, like table storage, a couple of cents a month. We'll talk more about the actual finances of the solution later on. A couple of cents a month. We don't need Cosmos DB. We don't need an Azure SQL database for this. Like, no, just simple table storage will do it for us. Finally, we need to create the additional tools, which would be a credential updater. Remember, we're going to have credentials in Key Vault, so we need to be able to rotate those every 90 days or so. So I built this. We're going to use a Python, I guess, a Python SDK to interact with Key Vault. And then we needed a static site to view the results. Remember that. Blazor. I don't know if anyone has experience with Blazor. I'm a big fan. Blazor allows you to use .NET technologies to develop full stack applications. You have Blazor WebAssembly, which runs off WebAssembly technology, and you're using .NET for just static websites. You have Blazor server side, which has a server and a front end. Very cool technology there. But anyway, yes, this is essentially steps in Azure, right? So again, everything's a little chaotic, but you might be able to get a feel for what changes I would have done. But anyway, we've got essentially all the services that we're going to work with here. Okay, so now at this point in my I guess experience or my time with this project, I've sat down with my colleagues. I've got all my key facts. I've approached the thing. I've planned it out, and I'm feeling more confident. So now we've graduated to a bit with a laptop and ready to work in Azure and whatnot. So we're going to dive into the solution, right? So for the solution itself, that first step is let's save the files. And remember, I mentioned that this is some sort of internal application that another engineer has built. So we need to get these files, these generated files, get saved to something. And I added a note there that says, it might be a little too small, but what it says is that these files are saved using a naming convention. And this is important for our next step that we have coming up here. But yeah, like I mentioned, we're going to use blob storage. So we have here processing blob storage, which are files that were manually downloaded are now going to go straight into blob storage. And blob storage, each file there is going to trigger an Azure function, right?
Quick question. So
yes,
the file that the internal application generates, do engineers put them manually in the blob storage?
No, it uses probably like blob storage API or probably SDK, like .NET SDK to just get the files to go straight into things. So that was automated as well. None of the process was manual unless there was manual verification or manual like resubmission needed to be done again. But that was a good question there. Okay, so yeah, we know that as soon as a file hits a blob storage, each file, not just like a group of files, each file, so we're talking about 50, 60 files, is going to trigger this process XML file here too. Now, remember that I said there was a naming convention, so the files were being saved, like, for example, I don't know, company name -something.xml. That naming convention was important because that is what the function would grab the name of the file and then go to Key Vault. It's like, okay, Key Vault, return me the credential that matches this naming convention. So you see there's a two-way arrow here because Key Vault would return that credential to the Azure function. Now, the reason that the credential, sort of like grabbing the credential is the first step here is because there is no point in processing the actual XML or the file if I can't find the proper credential, right? Because you're not going to be able to submit it to the API. So that's the first step here. So considering everything works out, we're like, okay, the Key Vault is returning now the credential back into the Azure function. And then the function has everything it needs to parse the XML and send it off to the submission website API. We're just calling it submission website. That's not the actual official name. So the function sends off that XML data with the credential and sends it off to the API, and the API will return some sort of response. Again, whether it's like successful or not successful response, we need to save the response somewhere. Next, that same function. Did you have a question?
Yeah. So the
Yeah.
credentials were file specific, or were they required as headers for the submission website?
Yeah, they were required as headers. So we would
Okay.
parse the Key Vault has a key value pair, and we would grab those and send them off in the call to the API,
Okay.
and then we would send the XML data with the call as well.
Makes sense.
Yeah, like the payload, I guess. So then response, again, we're using table storage to keep the responses. Table storage is a very, very simple, like you think of a table in a database, very, very simple service compared to something like Cosmos DB or Azure SQL and whatnot. So the function will save the API response to the table. And then, of course, we talked about archiving files as well. The function would then archive the file if it was a success. So this is the diagram according to if it was a successful submission, of course. Now, pay attention to this. And I have like sort of this rectangle here that just kind of tells you what is built in Azure and what is sort of on-prem. So remember that internal service was deployed on a virtual machine that lived on-prem. And then we had everything that's inside the blue, which is indicating a resource group living inside of Azure. Right? So pay attention here to sort of what you think you would change or what you think needs to be changed. And this solution at 50, 60 files runs fine. But if you throw 1,000 files at this, if you throw several thousand, which obviously this company wanted to obtain more and more clients, and as more clients would onboard to their catalog, they would have more and more files, right? So their goal was to be able to process these files. You start to hear performance issues with this current solution if you get into the, several thousands of files. But anyway, if anyone has an idea in the chat, let me know. But anyway, now it's not just the solution itself. I mentioned that I had also built a couple of helper tools. So the first thing was building essentially a CLI that would interact with a Key Vault using Python. So, if you used the CLI before, it was essentially something that said, username, like update, I don't know. I can't remember what my prefix was, but it was like update Key Vault. You would provide the username and it'd tell you, okay, what's the new password you want to do? And then it would go into Key Vault and update that correctly. Riship, you want to take a guess? Yeah. Let me have you take a guess before I show you the updated one too. Okay, cool. So that was the first. This is great experience using Python, using SDKs with Azure. It was a very straightforward thing, but it was my first time using Python in a professional setting, so it was a lot of fun. And it was something like pretty easy to run too. And then the next thing was a static results website, which I was using Blazor WebAssembly on the front end. And every time you would hit, and it was deployed on App Service, I believe, or maybe it was even deployed on blob storage, just like a static site. So every time you would hit the website URL, it would go call an HTTP triggered Azure function that would get the results of all the table and parse it to JSON and return JSON back to the site. And then the site was a very simple static site. It would say the file name, success file name, or whatever the response was, and the time that it was submitted, and whatnot. I like someone says Azure Queue Storage. Okay, you're getting there. That's a good guess. I like that guess there. It's a good guess there. So anyway, now I want to talk a little bit just about making my case for promotion, because we work, we build, we upskill because essentially we want career advancement. We want more money. Like, there's nothing wrong in saying these kinds of things. But earlier, even before I was in this role, someone gave me some of the best advice that I've taken in my entire career, which is like, the people who promote you don't necessarily care about the tech itself, because the tech that you need to be able to work with will change, like, I don't know, weekly, monthly, yearly, whatnot. They care about how efficient you can be and how you can save them time and how you can save them money. So every time that I would try to approach a promotion, I would make sure I can talk in ways that, like, oh, what was the actual outcome of my project? It's not like, oh, I implemented containers or I implemented serverless or I automated something. It's like, what was the actual outcome? What was the actual impact? We see mic drop bit here. You see this is bit dropping a microphone.
It's pretty good.
Yeah, I was very proud after this project, because I had been talking to my colleagues. They're like, we have so much time left. Like, this is all streamlined, that we know that this process is working, and all these kinds of things. So I was very confident. But there's a one line here. If I had to summarize this project, was my solution frees up 18 hours of manual work a week and runs for under $1 a month. Now, I don't really know what the salary of there was like, but if we, estimate that they were making, I don't know, $50 an hour, it averages about $1,000 a month. You're comparing $1,000 a month to a solution that runs under $1. To be exact, the solution was running for 30 cents a month. But I just put $1 because it's a little bit more catchier here. But for 30 cents. And the functions execution was free, because you have a grant, I think, per subscription with functions. I think it's monthly, of 1 million executions. So the compute is completely free. This was just storage. And if I was probably a little bit more clever with the storage, I could probably save, but 30 cents compared to $1,000 a month, massive difference. And then after this, I was promoted, and then I spent a whole another year as a junior cloud engineer at this company, and got a lot more hands-on Azure. And then years later, I'm here working at Microsoft. But anyway, let's dive into the fun part. I wanted to see, someone said either that or Service Bus. So Rishabh, did you want to take a guess?
Yeah, I was gonna say some kind of queuing service.
Okay. Yes. Queuing messaging. So when we think of distributed systems, which cloud is all about, like the more distributed that you can make it, the more advantage you can take of different services in the cloud and whatnot. You're going to get the best bang for your buck and whatnot. So yes, we are talking about having a messaging service, and I would add another function because that initial function was doing a little bit too much. So I would now abstract away the archiving, so the actual moving of the files and the saving of the response to table storage to another function. And that way that initial function can scale to process as many files as it needs to without hitting like any performance issues. So in this case, I have event grids. I think Azure has event grids. You've got, I can't remember. We have like 4 different messaging services. I know someone mentioned Service Bus, Queue Storage as well. But it really kind of depends on like what you're doing, like we're like aiming for. Queues versus events, and messages versus events and whatnot. Events tend to work a lot better with serverless and whatnot. So I would have event grid here, and then you can trigger an Azure function with event grid. So when there's a new event, and you can send like information with it. So file name and then response, and then that function would archive and then save response. I could probably do another function so it was just like one archives and one does the saving the response to table storage, but that was probably a little bit too overkill. But this would be the updated version of my solution. And if I actually implemented it in 2022,